biologist by trade. I've been doing this now for about 15 years or so. I will say that I was a former young earth creationist, actually very strong into it. Very strong follower of Mr. Ken Hovind on top of that. I followed Ken Ham and his Ark Encounter actually early on in the days. One of my things I was very excited for was the opening day of the Creation Museum, which due to a natural disaster in my hometown, I regrettably was not able to attend. But then life kind of changes in between here and there. The problem is I found that instead of having people to talk to about things, when I started having questions, I found people were more likely to withdraw and not want to talk about things. And then people would say, instead of when we would have evidence or things to talk about, people were much more likely to pull back and say, well, God doesn't want you to know the answers. But these things were not necessarily biblical. We are just talking about what we can see and observe with our own eyes. And that's kind of where, like, it's always nice to kind of have a discussion with people. But I've got to be honest, with this coronavirus, you know, I'm kind of stuck at home. I'm taking care of my kids, and it's just kind of nice to reach out and see if anybody else wants to have a discussion and whatnot.
Well, I can discuss probably anything you're considering there. I may be limited on time. Can you see me now?
Top of your head. Oh, yeah, I see you a little better. Perfect. Yeah, I can see you now.
Yeah, there you go.
I was originally going to do this in the garage because I figured then I can talk louder if the microphone wasn't coming through. But then I realized I wasn't having Wi-Fi because my Wi-Fi router is in the front room. So then I had to come back and, you know, do it in here. So basically between that and running around, this kind of ended up being last minute, but it's just kind of something for me to do and might be kind of fun in the process. So, but what about yourself?
Well, I don't know if you know anything about my museum, my fossil museum.
No, sir. I don't even know. I'm not sure I know who you are.
Okay. I'm the founder and curator of the Mount Blanco Fossil Museum in Crosbyton, Texas, near Lubbock, Texas. And if you saw the big mastodon there at Ken Ham's museum.
Yes, sir.
The Triceratops.
Yep.
Yeah, I did those. I restored them and
You excavated the fossils?
I just restored and molded those, but I've excavated thousands of fossils.
Okay.
I've worked with Dr. Carl Ball for many years and supplied stuff for ICR's new museum, the museum there in Dallas.
Well, as soon as you said
stuff for Ken Hovind.
Well, as soon as you said down there in Texas, the first thing, and you said Creation Museum, the first thing that came to mind was Carl Baugh, actually. And so then I started thinking, he's not talking Carl Baugh's museum because that wasn't the same name. So no, I wasn't familiar with this title at all. So
yeah, Carl's had his museum since about 84, I guess. I got into fossils back in 1980, working for La Brea Tar Pits with all the evolutionists there and atheists. All of them were atheists. Some of them said outright they were antichrist, and they weren't joking. So I thought, well, this is a place to be if we're going to learn anything about evolution. You know, here these guys totally into it. So,
well, if it's you know, you say Los Angeles. What's interesting is my cousin is from that area, and I would say there's a whole different wavelength of beliefs out there in general, not just necessarily on religion. But for example, I'm dealing with my cousin right now who is completely flat earth everything. He's talking new age ideas, and things are occurring in cycles, not necessarily that there was a creation or any start. I mean, he's got some ideas that are really out there. They don't necessarily follow with anything else. So but what I can say is I've been on field expeditions before. I've actually been out into the Badlands of Montana, North Dakota, Idaho, Wyoming. Originally, like I said, I started off as a young earth creationist, but the more I got out there and saw these for myself, I really do not see the evidence for a flood. And I'm interested in discussion. I'm not interested in arguments or anything like that. But from my previous experience, the way I figure this is probably going to go is I'm just going to hear probably a lot of the same thing. But that's, to be fair, where I don't want to be like that. I really legitimately want to hear what people have to say and what people's ideas are on things. We do know from psychology that there's a term called echo chamber. When people are in a culture where they're really used to the group of people that they're around, particularly in a church setting, they tend to get very resistant to new and outside ideas. And likewise, we know that people very much tend to resist any change when there's an idea. And so that's where it makes discussion really hard. And like I said, that was one of the things that made it hard for me initially when I was a young earth creationist, because people were not willing to have those conversations. It wasn't because people weren't willing to talk about things that I later, started turning more toward the theory of evolution. It was ultimately because I just started saying, I'm not afraid. I'm going to go where the evidence goes. Because the truth is, and I'd be curious as to what your model is on this, when I was talking to Kent Hovind years ago, actually, it was just a month before he got arrested in 2006. I was with him and I was talking with him, and I remember asking him a question, and I'm curious on your take on this. His idea was of the flood model. He was talking about Walt Brown's hydroplate theory, and he was talking about it being a kind of a quick freeze all around Earth at the time. And he said that this would have probably been due to something like a comet. And one of his ideas, and to be fair, he will turn around and say this is the Hovind theory, that way you can't blame Walt Brown on it. He would turn around and say things that, well, we would find woolly mammoths in Colorado, and these woolly mammoths had food in their stomach still, so clearly they had to have been flash frozen. And so he then claims he called the Denver Cryo Lab or whatever it was, and he said that their response was the only thing that could freeze something that big that fast would be something negative 300 and some degrees. Kent then makes the jump from there and says it must have been a comet that hit the Earth. He then makes the leap and says a comet must have struck Earth, that must have fractured the fountains of the Great Deep, that therefore flooded the Earth. And he goes from there. But the truth is, in science, we have to look at each one of those one step at a time. And each one of those breaks down when we look at evidence. And each one of those, to science, the more I feel like I opened up to the idea fairly that science really isn't this grand conspiracy. Like, people really are genuinely considering all kinds of woo ideas. Like right now, they're talking ideas with, coronavirus possibly being created in a lab. I don't accept that. I think it mutated naturally from bats, just like SARS. But I am willing to accept those ideas because it is a hypothesis. And we look for the evidence and we try to find wherever that evidence is and try to see if it makes a cohesive theory. As Karl Popper said, we try to prove things wrong. We can't necessarily prove things right. And so that's what Kent Hovind said with his model. Anyways, I want to let you talk, but my point is that little things like that, it was always, whenever I brought those questions up, people would instantly turn away and say, those are things that you can't know the answer to. I say that's complete bull. Like, evidence is out there. We have to find it. If it leads toward a young Earth, I will follow it. I honestly will follow that. I do not hear that same response from creationists, and I'm really sad to say that. Would they follow the evidence wherever it took them? So anyways, I talked for a while. You can go ahead and talk.
Well, I know all those guys. I've dug in all those places you mentioned there and many more. I know all the main guys like Ken Hovind, Carl Ball, the Morris brothers, Ken Ham, all those people. And I know where they stand on things. But I also am connected to a whole other group of guys that a lot of us are field workers. We get out and go in the dirt and been all over the country, some of us all over the world. So we look at, we're not just reading stuff out of books. We do that too. All of us have libraries. But I have a lot of evolution friends. Some of the top paleontologists in the country are my friends. And I know what they think, and I listen to them. Like I said, I spent time there in Brea tar pits with the absolute enemy of creationism. However, because I had a passion for the bones, for knowledge,
not to interrupt you, why is the Brea tar pits the enemy of creationism? And that's a legit question. I don't know.
I'm referring to the atheist and the Antichrist.
Why would
People
it
that said
be,
they
and
weren't.
why would the Libre, you can, I don't mean to interrupt you, I really do apologize, but why does the Libre tar pits, why is it the enemy of evolutionist
No, I
atheists?
didn't say La Brea tar pits was. I said the atheists that worked there. In other words, if I was a closed-minded person working with a bunch of atheists who call themselves Antichrist at an evolution museum, would not be where a closed-minded person would find themselves. But I
Okay,
went right in there with them.
okay, because
In fact, I went on dig.
my initial take was I thought you were saying the Libre tar pits was evidence they couldn't refute, and therefore it was something that they brushed under the rug or something. And
No, by and
that's where I was
large,
lost. Yeah.
the as far as the La Brea tar pits goes, it's pretty much like they say at the tar pits. These
I'm
animals came
familiar.
there, they stuck in the tar and drowned, and finally filled the whole place full of bones. But I know the bone count there. I've worked with some of that stuff, and I know the place pretty well. I've worked in other tar pit stuff, and if a normal environment, if you had one saber-toothed cat or two saber-toothed cats a year get trapped in the tar, and 10 or 15 coyotes, wolves, and all that, in about 100 years or several hundred years, you'd have all the bones there. So it wouldn't take very long to fill up the tar pits. They have to be post flood because the tar seep there has water running over it, and it's all above ground. It's all above the dinosaur layers. So that's there. Now since the guy that owned the place died, they told me, said, we're going to change the dates as soon as he dies. So they've probably put in dates like 24,000 years on those animals. I don't know what they did, but I don't have much contact with those people anymore. All
Understand.
I'm saying is the best way to know a horse is to get around a horse. Best way to
So,
know what
oh, I
evolution
agree,
is.
being out in the field.
What's that?
Oh, I agree, being out in the field. I'm curious. The thing is, I'd have to see more about the Libre tar pits. I do know they are relatively recent, at least in evolutionary history. Obviously, in younger creationism, it would have been all the same. It wouldn't take me long to look up a geology map and see if they would actually have had dinosaur layers under that. But as far as there being bones, my first assumption would be the Libre tar pits was not an old formation. It wouldn't have been something that was long lasting, but that I don't know. As of right now, it's at least 11,000, if not older than that. So,
Well, there are a lot of those same animals in the sand and gravel around Los Angeles and that area. There are almost no dinosaurs in California. Very, very few.
now why would
But
that be the case, out of curiosity?
sure, I'm not sure they were close to the ocean, so a lot of whatever was there probably washed into the ocean during the flood or during the abatement. I don't really know, but I looked at the geology there, and a friend of mine went up to a place in Northern California where the flat strata had been tilted up, and there are these dinosaurs walking, not uphill, but they walked across the limestone mud, left their tracks, it got covered over, turned to stone, and tilted up later on. That's about the only dinosaurs I know anything about in California.
And you understand the explanation given by geologists for why the fossil layers tilt up in that case?
Why it tilted up?
Because it's plate tectonics, and you're also talking it's near the San Andreas Fault where there's massive subduction taking place there. That would be the mechanism, which is why when you drive through the West, you're always seeing the mountains. And this is where Walt Brown, Kent Hovind, they use their hydroplate idea because they see that evidence too. But we have plate tectonics, and it creates these sine waves. I forget what they specifically call, but it's within the rock. When you get on an edge like that, or in any type of an area where you have nonconformities, et cetera, you get layers of rock which are tilting, giving the appearance that it was upright rather, and they have what's called the law of horizontal deposition, even though it's not necessarily horizontal, but there's mechanisms. The earth is dynamic. In a young earth model, the earth is not dynamic, but in a geological model, we have magma underneath us. Just like on a stove, you have hot liquids. They're constantly pushing liquids up. That pushes anything to the side, which then gets subducted, and then it goes back to the center. It's something anybody can see in a microwave if you put honey in a microwave. The Earth is constantly moving. So if you weren't to take that idea that, just assuming geologists were correct, why would that not also be explained by subduction and plate tectonics, turning the mountain
Yeah, probably.
sideways?
I'm sure that probably had a lot to do with it. There's another theory that has some merit, and that is that after the Earth was covered in water and God told the water to go back into the ocean or back into the fountains of great deep, whatever, but that released the pressure off the land, which caused the land to rise up and create the mountains all along the ocean ridges. So there's something to that.
And
that certainly is borne out in the field.
And that is one of those examples where, as a scientist, we would say that's a hypothesis. It doesn't sound like it's likely, but it is worth investigating if we obviously have a budget or something. But it isn't a conspiracy necessarily. We would look into that. But it's something that even if it was demonstrated correct, it still would have to cascade all the other evidence. Because, for example, we have, well, one second, we have volcanoes. They're erupting lava out all the time. Magma, we can be pretty certain, is under the Earth, and the Earth is really hot. Doesn't that alone explain plate tectonics, having hot liquid underneath, causing the churning, the movement of the plates, just like you would see on a stove? Why would you have to jump then to a hydroplate theory, I guess?
Well, yeah, I think those things all are probably certainly the flood dynamics, the abatement dynamics, then what's happened in the last several thousand years, all of that stuff figures in. It's a complex, what we find in the world today has gotten there in a complex way. Have you ever been to Dinosaur, Colorado, and the western slopes, those
No,
beds out there?
I'm familiar with it. I have wanted to go there. I have yet to have gone to Colorado. Actually, that was on my next year's plan, but with this virus, that might be postponed as of right now.
Well, we've been digging over there in near Dinosaur on a ranch, a couple of ranches actually, since 1995. Sauropods, allosaurs, crocodiles, ankylosaur, all the stuff that you'd expect to find, fish and turtles.
Okay, can I go ahead? Sorry.
Okay, I want to make a point about Blue Mountain. Blue Mountain is where this ranch is, and you look from where the dinosaur side is, we're working. Look south of there, there's a mountain peak stuck up, but it's got a big draw cut in it from erosion, like a giant river ran through there. But of course, there's no water runs through there now at all. It's just seasonal rains. But
you know what?
That was caused by the abatement. When that land was all still flat after the flood, so when the abatement happened, it cut down through all those strata. And even when the mountains raised up, that brought that erosional valley up in the air where it couldn't possibly have happened any other. It had to be flat when it eroded.
So this specific place you're talking about, I'm not familiar with, but I am familiar with the process of, like you said, having erosion at the top of a mountain or something high up there. The geologic explanation for that, and if we look, the Colorado Plateau is right there again, right where you have the Rocky Mountain, right on the Great Plains, and we have the Colorado Plateau. The geological explanation for that is obviously that's where you have the mountains at. And yes, the Rocky Mountains are young. We're talking only within 100 million years old or so. The Rocky Mountains are a younger structure. They were lower on the ground. And at that point, we actually had the Great Inland Seaway, which was right there too, which was the mechanism for erosion, which would bring me to my next question, because you were talking about dinosaurs. Where would you, if you didn't have a map, well, you had a geology map, where would you know where to look for a dinosaur? What would be the explanation? Just to go out and look in the dirt until you found something? What would be the explanation for where you could look specifically to find a dinosaur?
Well, that's almost an unfair question because now I've been doing this for 40 years. So I know the strata everywhere in the world and what it's going to produce. But you always have to find a draw, a mountain that's been uplifted, or some sort of a flood condition to find a buried strata that's been exposed, tilted up, are cut down through. That's how I would find them.
Yeah, we would call
But
those
in
geologic
the
processes.
Morrison, do what?
Oh, we would refer to those as geologic processes. So basically, the geologic model says that we're talking, and keep in mind, dinosaurs, obviously, you probably are familiar with the evolutionary explanation that dinosaurs lived for a very long time. In fact, the time between Stegosaurus and Tyrannosaurus rex was greater than the time between Tyrannosaurus rex and humans, only 66 million years. Around the time of Tyrannosaurus rex, we had what was called the Great Inland Seaway. The Rocky Mountains were much flatter. They were not as tall as they are today. So that is one of the mechanisms for why there was erosion at the top. The seaway carved its way right through the middle. I wish I could pull up a diagram here, but I have to figure out Zoom and how I could show it. But the Great Inland Seaway, actually, I'm going to try this here. Inland Sea. It carved its way in through the middle of North America. Actually, I found a picture. Let me pull this up here. And I'm actually trying this out because I'm kind of new to the Zoom. And I'm going to see if, oh, there it is. It looks like it. See if this popped up here. Okay. Great Inland Seaway carved its way through the middle part of North America. And this was, again, not for all the dinosaurs, but just about 66 to about 70 million years, give or take. And what it did was divide North America into two continents. It's why you see over here on the East Coast, we have what we call the tidal plains, and we have Appalachia, which was up at the time. Great Plains were somewhat under, but the mountains were a lot lower back then. Now, what we find is on this side is where we find the dinosaurs. And this is because with the water there, we have a mechanism for their rapid burial as well. And that's another interesting point about dinosaurs such as Stegosaurus. Why were those dinosaurs not, why do we not find those in abundance? And the general explanation is that they tended to go more inward away from the sea. It's really not about how many there were, first of all. It's about how likely they were to get buried when they usually went near a source of water. So right there near Colorado where you're talking is our source of erosion on top of that. And that was around 70 million years, which is by no coincidence the date of the date of the Rocky Mountains that you were talking about. So, but that is generally the explanation given to that.
Okay, you're familiar with the layers there in the Hell Creek and the Lance, the Morrison,
Yes.
all that stuff.
I gotta figure out how to put this back on here. Oh, you're fine. You can keep talking. I am just trying to stop share. There we go. There we go.
If you look at all the strata from, well, it's the same up in Canada, all the way to up into Alaska, down into Montana, South Dakota, North Dakota, Utah, Colorado, Oklahoma, even Texas. What you find are flat layers of strata. Some of them an inch thick, some of them tens of feet thick, and they all contain pretty much unweathered bones. So some of them are disarticulated, but the place where we're digging there at the LC2 quarry.
Did you say that all the bones were unweathered in the Hell Creek area?
I've never found a weathered bone in the Hell Creek.
I have found weathered bones. I have pictures of weathered bones, actually. I have pictures of not just, obviously they're articulated, but weathered, they're not in a single piece at all. So
no, I'm talking about weathered before being buried, like the bones that lay around on the surface for 10, 20, 30, 100 years, you know, they tend to deteriorate. I've never found that, although by virtue of my belief, I would have to say there were dinosaurs living and dying for 1,500 years before the flood. Therefore, you should find dead bones laying around. But as far as them being weathered, like cow bones out here in Texas get all cracked up and then finally fall apart after 20 years, you just don't see that in the dinosaur beds. They're all in great shape.
But aren't you assuming that the flood is what caused those to fossilize in the first place? Why not the explanation that they were near a water source and that's what got them buried, and that's also the mechanism for articulation?
I've collected South Dakota over through to North Dakota, Wyoming, all those places. If to get those things buried, you have to have floods that cover half the state.
No, you don't.
100
You
times.
don't. No, you don't. You don't have to have that much water to get them buried. Not at all. They just need to, it could be something where they're getting a drink near the source of the water. It could be,
Okay,
they're
I
walking in
talked to
a muddy area. They do not have to be buried by a flood in order to get fossilized,
well,
if
the
that's my
problem with that
understanding.
is, the problem with that is if that were so, and a dinosaur came down to get a drink, somehow got buried in the mud on the edge of the creek, the next flood would just wash him out, wash him down the drain.
Not
But you don't
necessarily,
find that.
because there's not always a flood after another flood, especially if it's not, especially if it's seasonal or something. There doesn't always have to be that. I was trying to
Well,
find this here. I was trying to find this here
evolution,
too.
evolution paleontologists like Bob Barker. You know Bob Barker?
I do know yes, I do.
Yeah, he was his explanation would be local floods got out of the banks, buried dinosaurs and all that. But he knows as well as I do that those things spread for hundreds of miles. You can't. That is not a local flood.
I'm not sure of that source on that, and I'm pretty sure Bob would probably disagree with that conclusion too. This picture here I took on an expedition last year. This is actually in the Hell Creek formation. This is actually the Fox Hills formation right below the Hell Creek. I was a few miles just south of the Hell Creek, and you'll notice the rocks here are a lot lighter. So this is the layer that was actually below that. Down here is where I was trying to explore, and you'll see there's a little creek down there. And I snapped this picture because I thought it was kind of interesting at the time. This is kind of a zoomed away image.
Cow pelvis?
It's a little,
cow pelvis?
What's that? No, it's actually a skull here. I'll go back in a second. This is just kind of the takeaway. This is nothing regarding anything in particular. I just found it interesting because I was walking and I thought this is a kind of a cool picture because I saw what was basically fossilization in the process. This was a washaway because we're talking on the edge of a cliff, like right there. And then down into this little crypt down there, if I zoom in, is a skull. And the skull is obviously starting to weather completely. It's completely disarticulated. There's no other bones. And for all we know, the bones could be a little further down and buried by water. But the only thing we need for fossilization is we need a way to stop the further decay. And that means we need to cut off the oxygen. We need to bury it with something. Sediment is really good for that. And that will pretty much inhibit any further decay. This fossil, because you were talking about other floods, if it does not rain again anytime soon, and the time I was here, it actually hadn't rained in a while, this will be an example of a skull that will weather away completely. And it depends on the conditions. It can take years, it can take months, and deserts, it can take decades even. But in this example here, this is going to be an example of a bone that will sit and it will weather away unless more mud washes down and continues to erode it. But for all we know, the rest of the bones could have been gone, they could have been eaten, or they could already be buried. So, and this is just, like I said, right next to the Hell Creek Formation. Go ahead.
Cut in there. What you got there's the pelvic girdle of a cow.
That's not a pelvic girdle of a cow.
Yeah, that's pelvic girdle of a cow. And that thing in the middle, that's a sacrum, turned upside down. And probably the rest of the bones are either up there or down below. But yeah, in another 20 years of rains, that will just wash on down. The varmints will eat it because it's still bone, and it'll never turn into a fossil because it's on an incline there, which will continually drain down. That looks like Morrison mud there. You said it's Hell Creek or Morrison?
This is actually the Fox Hills Formation, which is not the Morrison Formation.
What's in Fox Hills?
Fox Hill is a localized area. It's around Hell Creek. It's kind of a subdivision. It's one known for its preceding the Hell Creek Formation. So we're talking around 66 million years. It was a small localized period of time. But I'm curious why you say it has to wash further down and it'll eventually be gone. Like, why can't this get covered up with mud? It's not a steep incline in this spot. And even if it was, or it wasn't, why does it have to be assumed it's a steep incline? The point is, you're burying it with sediment. And when you got heavy mud like this is inhibiting further decay. And that is going to lead to permineralization or any other type of mineral replacement.
Well, I mean, it looks to me like it's in a wash. Wash it after 20, 30 years, that will probably just continue to wash down to the bottom level.
And
I mean,
let's say it gets to the
it might
bottom
get
level,
there.
can it? But let's say it does get to the bottom level, we would call that alluvium when things continue to pile on top of it. So then wouldn't it just fossilize at that point? Because again, all it has to do is get covered up with mud, and then it has to prevent the aerobic bacteria from breaking it down, and that will over time lead to the permineralization. All you have to do is cover it up to prevent it from breaking down. So even if it washes down, it's still going to reach a bottom at some point where all the mud will, if anything, that's going to lead to even quicker fossilization because it won't be sitting exposed.
Well, anything downhill like that is probably eventually going to wash away. There was a creek up there in Montana on the Bice ranch. The guy was telling me they had a cow fell into a quicksand bog and sank out of sight. And about 5 or 6 years later, she washed out, and they said the bones were petrified. But that's in really heavy iron sand and clay there. So it doesn't take long for something to mineralize. That's for sure. But all the other cow bones up there, horse bones and all that, they sometimes get buried with a local. They die, and the water washes down, covers them up. So weeds grow up, maybe a tree, and for a while they become sort of a dam. But eventually they'll wash out, and there's not much. There's not much going to get petrified like that. Not even in Montana, where it's not where it's the conditions are pretty good for that. I've collected thousands of buffalo bones down here in Texas and other places, and I don't think any of them are permineralized. And they're supposed to have been there for 10, 20,000 years, which I don't believe. I think they all got there in the last 1,500 years, maybe. I've worked the strata there for about 20 feet, and the deepest ones have the most root etching. You know about root? You ever seen root etching on a bone?
Yep.
Yeah, it's really interesting patterns. You even find that on some of the bones up there in Alaska, on the buffalo bones and that sort of thing up there. Occasionally, you find dinosaur bones that are root etched. All that tells you really is they were near the root zone for several years. A lot of these horse bones out here in the Pliocene beds where the stegomastodon and all that is, a lot of those things are completely root etched, but they've been near the root zone for about, for years. They, as things erode down, the roots grow backwards, and they finally get you all those bones and eat the surface of them.
Okay.
So,
but so you've seen the fossils, and you're talking about all that, but I really quickly am curious though, because you said still, regardless, if a fossil washes to the bottom, it'll eventually just wash away regardless. But where does it wash away to? When you go you've walked in the ocean, even if we're talking the ocean, and this was where the Great Inland Seaway was, when you get further from the shore, it just gets muckier, and that's even going to further covering something up and burying it, especially with sediments washing into the ocean. Why?
Well,
I just have to say, it's not an explanation just to say it'll just wash away, because where is it going to wash to? Eventually, if it washes away, it's going to have an even better chance of getting buried, and it's not going to look like this where it's going to be exposed. This is a fossil likely not to get buried and not to fossilize. But it's kind of cool just seeing in the act and how it's disarticulated and whatnot. But that's what I'm asking is, why does washing it downstream make it just something we can ignore? It's actually how fossils form.
You should go back there every year and check on that pelvis.
If I could afford it and it wasn't the virus, I would enjoy it a lot. I actually have a numerous stuff I've documented locations of. Some of them in dry places, like the Two Medicine Formation, I'd love to get back to, but the problem is it's just hard to get to the spots. I'm not a professional paleontologist. It's all amateur, and I cannot collect the fossils either. One thing go ahead.
Let me throw another thing up for you. Up there in the near Lemon, South Dakota, there's a ranch we've been digging up there for a long time. Down about 65 feet of sediment, there is a layer of bones about 3 or 4 feet thick, mostly Hadrosaurus, some Dromaeosaurus, some other, maybe an occasional T-Rex tooth. There are thousands upon thousands upon thousands of animals buried in that layer. And they go over into other parts of South Dakota.
You know,
The
that's
Rouge
taken place over a
Formation.
long period of time too. That's where you're getting,
Well,
of course, there's going to
could
be
be
a
a
lot
long
of,
period of time because they're all in great shape. They've never weathered until they weather today.
how
But
about
you've
this
got
here?
areas there where there are tens of thousands of dead animals. You're just not seeing that today anywhere, not even the ocean. And by the way, they've done tests on whales when they die in the ocean. I think they say in less than 10 years that whale is gone. Nothing
Again,
in the ocean
it
today is being preserved.
there's not one, well, it depends because whales typically don't live near the shore. And obviously by the time they sink to the bottom, there's a lot of bottom feeders in that specific place. There's different areas of the
Well,
ocean where
that's
we
the
have
problem
dead
of
zones
all
and we have the
oceanic
shoreline.
areas.
And you know,
You'd have
you are right about a
all the-
comment here, and that is that fossilization is a relatively rare event. You know, it is a very relatively rare event. One thing I am curious about is this was taken, actually you can see the Hell Creek Formation, Fox Hills Formation, and a few others in this one frame here. How does a flood
Right, yeah.
model account for this picture of the Badlands?
Okay, see all those flat strata? They extend
Yes.
for miles,
Yes.
miles and miles, and all the canyons there eroded down between them. You can't get that with a regular erosion. You can't get that by regular creek deposition. That all had to be done quickly with soft layers, hard layers, soft layers, hard layers in deep water. And then when the deep water ran off, it cut that canyon you're looking at there. And now it's eroded down maybe in the last couple thousand years, 100 feet or so. But that is not forming anywhere on Earth today.
Where do the layers come from in that picture?
That big hill back there in the background,
Yeah.
that entire canyon there was full of that same flat stratos of mud. Nothing can do that except if you did that, you covered
And
the entire Earth in
you're
water.
actually right about that, except geologists would say this is glaciers retreating in this place. And then there was obviously melting that occurred because it did leave water behind as well. It's a slower process than, you know, what the flood model is suggesting, but it is carving up, to be fair. You are on, but my specific question here is, where did the layers come from in there? The specific different bands.
They had to come out of the bowels of the Earth when the flood occurred. When the Earth cracked and split and the fountains of Great Deep opened up, brought all that mud and water up. Some of it probably scorching hot, different consistencies of rock, which melted.
Wouldn't the temperature tend to reach equilibrium with all that churning? And so you wouldn't have specific zones of hot and cold?
Well,
isn't that thermodynamics?
Are you familiar with John McKay over in Australia?
No.
Or Guy Berthaud?
No.
Okay, Guy Berthaud is a Frenchman that came to the University of Colorado, I believe, or one of the big labs there. They built a trough with a glass side on it. I think it's about 18 inches deep, and they put a camera there, and they introduced flowing water with different colors and densities of sand, just to see it how strata built up. What they found absolutely shocked all the geologists that watched it, because what happened was all the layers formed at the same time, top and bottom forming at the same time. And if they stopped the flow,
well, sorry, go ahead. I thought you were done.
If they stopped the flow, then it'd start with the bottom layers on the top again, and then go ahead and do the all the way down top and bottom at the same time. John McKay over in Australia has built a smaller version of that, shows the same thing. That
you're talking
what you're looking at.
You're talking hydrolithic assortment. You're talking sorting by particles and all that stuff. Like because the typical creation explanation is you take like a container of water, you put sand in it, you shake it up. You're saying it sorts by layers. Is that what you're saying?
Yeah.
That's where I used to go for that. And that is an explanation that simply does not work. Because what it does, if you actually do this, and I'd be curious of that study you were citing, because what typically happens is when I look up, and this is where, like I said, when I was a young Earth creationist, nobody looked at the source. They would say things like that, like it absolutely shocked the geologist. And they would say statements like that, but when I would go look at the actual study, it was nothing like that. And it was misquoted. In fact, it was maybe so poorly done, I would go back and say, why is this even being used? And people then didn't want to talk about it. So I would be curious to see that, but I have actually tried that. You can put sand and water. In fact, you can put all kinds of mud and sediments, and you're right, it will sort, but it sorts by density. It doesn't sort by anything in particular. What we see here actually are bands of coal. And I know this because I actually went and looked for these bands, because the specific band I'm standing on right now is actually the KT formation. This is where, well, we could say where the hellfire occurred when Earth was struck by the asteroid. What's interesting about this is actually all the Hell Creek Formation behind me. And I was asking earlier about how we find dinosaurs on a map. Well, one thing is nobody told me where the dinosaurs were. I just remember thinking, well, this is rough age. And one thing we look for when we look for fossils is the right type of material. For example, you can have rock that is 66 million years old, and it's the right age of dinosaurs, but it could be gravel-like. Now, gravel-like material and thick, coarse sand is not very good for fossilization, because in order to fossilize, you need some light type of sediment to actually get in there and permineralize. So not only do we have, I should say, sediments of the right age, we also have sediments of the right structure, enough to actually cause good fossilization. So I went to this area, an area relatively unexplored, at least I'm not familiar with it. And one thing I was looking for was the KT formation. And I knew it was going to be somewhere around here. It was just kind of a general area. And then I noticed this interesting conformity up here. You'll notice it's a lighter structure on top, and then it gets dark gray. I took a walk, and sure enough, right, whoops, going a little backwards in my pictures. Sure enough, when I did, you'll notice this is where it's lighter up here and darker down there. When I took a walk and ran around to the side, I noticed I was getting a lot of these erosion patterns, and this is kind of, to be fair, like you were saying, you see rough erosion like you would expect if it's just left out to weather. When you look closely, you do see rough weathering. I don't see any clean lines like this, and that makes it really hard to see. So what I did is started digging there. And sure enough, when you get close, you see a very distinct layer, dark black, and it's actually coal. Now this area is not easy to see, so if I go to another area, I found the KT formation in an even better spot. And this was toward, later on down the pictures and all that, right here. Hell Creek down below, and this is about 3 miles away, completely unrelated area, and you'll see this is the area above it, and here's the KT formation. And you'll notice we see a relatively distinct band, but it is kind of rough, because again, this is an area of time that is relatively short, but it's still not perfectly clean. But you'll notice an abrupt disruption right on top of this here. Nowhere above it in this layer has dinosaur fossils ever been found. And I did look, in fact, in this picture here, whoops, I found this fossil of petrified wood. I found several fossils actually like this. I could not find any fossils of vertebrates of dinosaurs. In fact, I couldn't find any large vertebrates at all. Something was different here. But I went lower, and right there is where you see white layer. This is actually volcanic ash. Turns out this ash has been analyzed. This ash dated 66,040,000 years ago. If I zoom back to a further image here, this is one of my favorite pictures. I stood at the bottom of the Hell Creek. You can see the KPG formation. And right here, spotted vertebrate fossil.
Okay, well, I've been to places. I've been to a lot of places just like that, but let me ask you this. Where'd all that sediment come from?
I didn't know you were done asking. Well, it's kind of like, where does sediment come when it ends up on your porch? It comes from somewhere else. In geology, generally you have higher structures and it moves from high to low. Generally, those high structures are pushed up by plate tectonics, by some mechanism of the earth. They're pushed up. And then when erosion occurs, the alluvium comes down, it ends up on some other structure.
Yeah, that's the same thing that I asked Craig Dershler, Dr. Dershler from the university there in New Orleans. I asked him, where'd all the mud come from? He said, well, the Rocky Mountains eroded and all the stuff washed down. Well, the Rocky Mountains weren't there to wash down.
Mountains were
You've got more than the Rocky Mountains, and that's strata? There's
This
more
is
than
actually,
twice the Rocky Mountains there. Let me ask you this.
wait, hang on one
All
second.
those,
That's not, hang on one second, sorry. In answering that question, that's where sediments come from. This particular sediment was here because this was level ground at the time. What happened was when this was all level ground, it later got eroded out from a glacier, so they weren't piled up like this. This was all level ground at the top up there, and the glaciers carved all this out. So that's kind of
okay,
where, like, this is that specific example. Go ahead, sorry.
all right. Let's say maybe that's what happened there. But all that entire area you're looking at there was all flat stratas, some of them an inch thick and so on. Just like I said, how did that entire area get covered with an inch of dirt and no erosion happen?
It's not an inch of
Hundreds
dirt.
of times.
It's not an inch of dirt. That's a misconception too.
No,
What it
there's an
is,
inch of dirt, there's a quarter inch of dirt, and there's a foot of dirt, and there's 6 feet of dirt. But it's
well,
all
actually,
flat, uninterrupted.
nope,
You know who
actually,
Paul Sereno is? You know Paul Sereno,
I'm sorry, I was trying to, go ahead. What were you asking?
Paul Sereno, you know, the guy that discovered supercroc?
No.
Okay, he's like one of the big paleontologists. He was showing his digs over there in Argentina, I think, digging up Herrerasauruses. And the strata is red, white, red, white, red, white, red, white for 400 feet. He says, you know, we found Herrerasauruses in all the layers. Now, we know there was evolution, but like just wasn't there. Like, oh, way up there in the sky, somewhere that we can't see, there's proof, but we can't see it. I said, Paul, I said, all those stratas there look just like it is over here in South Dakota, North Dakota, Montana. Where are your fossil canyons?
I'm a little
Where are the
skeptical that the
canyons between all
conversation
these
took
flat
place
layers?
quite like that,
He
but
just
anyway.
acted like I was talking Spanish. He quit talking. He had no answer.
I'll give you an answer because I was trying to get back to this comment here because you were saying, how can you have an inch of dirt last for millions of years if that was your question? First of all, it didn't last millions of years. It lasted numerous amounts of time. For example, this coal area lasted, they could say, a few decades or even a few years. It depends on where it was in the earth. This Hell Creek Formation lasted actually a few million years, and yet it could be various thicknesses all around the earth. The point is, though, dirt can end up somewhere because it's blown there, but in the case of Hell Creek Formation, this was actually an ancient seashore. So for example, right now, and I'm not sure of your stance on things, but if you go near any shoreline, you have the oceans, which in our lifetime has been pretty solid, but the climate is changing. The climate has changed in the past, even over the last, million years, for example, many times. And that changes sea level. Every time you have sea level change, you have huge amounts of mud and sediment deposited. And so we're not talking, this is just one little bit of breeze blowing dust on someone's porch. We're talking this entire area at one point was not necessarily flat, but relatively. And as the seaway was moving inward, it was depositing huge amounts of mud that gradually got more and more piled up. And honestly, it's kind of crazy to think about, but at the same time, that's where we're seeing clams and all kinds of little things in there that come from the ocean. Now, creationists would say these come from floods, but what I was trying to say earlier is, how do you explain the coal layer in there? When coal specifically comes from burning plant matter, specifically compressed burning plant matter. You're also seeing little bits of debris in here. We call them spherules, which we believe came from the asteroid that impacted in Yucatan. It wasn't really well known about 20 years ago, but now we have evidence when we look at these little tiny spherules. The closer we get to Yucatan, the bigger these spherules get. Something struck Yucatan 66.04 million years ago and sprayed these around the earth, but we don't find these in China. I find that fascinating. It's telling us a story of something that happened. The earth was a scary place at this time when this was relative ground level, and it scorched everything at this time. Now, afterwards, the climate continued to change. The ocean of the Great Inland Seaway gradually moved further in, deposited more mud, and it changed. It maybe went in and out, but over time in relatively same type of ecosystems, it deposited more and more mud, and numerous other things could have happened between here and there, but the last phase we get is glaciers, which carved all this out. And you'll see it's not a clean exposure, as sometimes creationists will say, well, why is it so clean? It is in many cases like the Grand Canyon, but this is a place where it's not clean at all. It's not clean at all. In fact, it's very rough. I have to get in there and really chisel away to see any of the lines, but from far away, it's a beautiful dark line where we can see these things. But again, when you put stuff in water, when you sort stuff, it sorts by density. It does not sort by composition. How does coal get one distinct band? How does mud of a certain texture get another band? And then we get larger sand like we get up here and a different band up there. It's not sorted by density. And that's my question.
If you have the fountains of the great deep opening up all over the world, that's bringing up mud and water. And that mud is flowing. And in the Hell Creek there in, say, in Montana, that flow is southeast. So there's an orientation to it. It's a one-time event. It's not millions of years separating them to form 200 feet of sediment. It's just not there. Those flat layers, I'm telling you, I know they go for hundreds of miles.
They do.
And you cannot, you'd have to have one layer of flat, hundreds and hundreds and hundreds of layers of flat stuff. And where do we ever see on Earth where hundreds of miles, thousands of miles in some cases, are covered in little flat layers, and the dinosaur bones just lay there in great shape for hundreds or thousands of years? It's not happening.
You actually don't need it to be for hundreds of miles perfectly flat. What it has to be is relatively the same ecosystems at around the same time, because you're getting roughly the same type of depositions. That's what the stratigraphy is telling us, the layers that are forming. It has to be roughly the same type of ecosystems and condition. It doesn't have to be perfectly flat. We call in geology the law of horizontal deposition, but technically it doesn't have to be perfectly flat. But you were saying again, how can the fossils stay there for millions of years? And again, I was saying that earlier, that's not what fossilization is about. Most fossils don't ever form. But if they are covered relatively quickly, usually if an animal dies in some shallow pool or if it dies near a shoreline, and by the way, you know this too, that people even need to live near water, and most humans through all history lived near water. If you don't, you had to have special adaptations or you would die. And so it's no coincidence when we find animals or fossilized, they probably died near the water.
Well, here's a problem with that though. All over North Dakota, in Alaska, Canada, all the way down South Dakota, North Dakota, Montana, all those places down to Utah, Arizona, they're all covered with millions of dead dinosaurs. That's not reasonable to say that's a little layer here, a little layer there, hundreds or thousands of years between. That's just not feasible.
Why is it not
Besides
reasonable?
that, if you look at the ocean today, where are the oceans burying any animals today on the shore and forming those kind of sediments?
Well, animals are buried all the time. In fact, the shoreline's a perfect place for it to happen because you have that sedimentation.
Show me one.
Well, go to a beach and stand. All you have to do is stand on the beach, put your feet in the sand, and your feet will get buried. I mean, you'll gradually start sinking, but even
but then they get uncovered the next time it comes in. There was a guy that was digging up trilobite tracks up in Oklahoma. He said there are 200 feet of these tracks and no dead horseshoe crabs or trilobites. I go, how do you figure that? He says, well, the creek flowed in and deposited a little bit of mud. The bugs walked across that, and another one came along and all that. So 200 feet of this creek, one little inch at a time, quarter inch at a time, formed, and those tracks are perfectly preserved, and nobody died in that whole time. It's ludicrous.
And that's the thing I think you're misunderstanding right there. It's not forming millimeter by millimeter at a time. It is usually it could be a landslide. It could be, in some places, little layer by little layer. A lot of times the trilobites are just dead. They die, and then gradually, especially being exoskeleton, they preserve a lot easier. But if they're
that's
an
the
area,
problem. I've worked on a lot of trilobites. In fact, I'm the guy that molded the rilling, the Sahelanthropus plate that at one time was considered the best plate in the world. There's a lot of them bigger than that now. But in Morocco, you've got literally trillions of all kinds of trilobites. They're in great shape. Some of them have fallen apart, but for the most part, they're all in great shape.
which is remarkable. But again, we owe that to their exoskeleton that they have.
No, a lot of them have their feet on the bottom of them.
They have what?
They still have their feet on the bottom.
which are
But
still
those things are
it's
like
still an
horseshoe crabs.
exoskeleton. It's just like an insect.
If,
They have an exoskeleton.
well, if they're a shell, they're like a horseshoe crab. If
Yeah, it's
horseshoe
an
crab gets
exoskeleton.
buried, his integument will fall apart, but the bones are all there. I mean, the shell is there. Same with a trilobite. But knowing how the bottom of the ocean is today with crabs and streams and things like that, there is nowhere on Earth today that millions of horseshoe crabs could or are getting buried.
I don't think geologists would say that it's always necessarily a slow, steady burial. You get some cases where there is some catastrophism taking place. There's going to be mudslides. Which might explain huge burials or little things like that. But surely these animals die, and they lived at the bottom of the ocean. And that also brings up another point. Why do we typically find trilobites in shale in abundance? We find them in other things like sandstone, mudstone, but they are very common in shale. And that is because shale, it's ancient mud, clay-like very fine sediments, and it's at the bottom of the ocean where these creatures lived. Possibly a shallow sea, perfect place for burial, not to mention you're talking animals with an exoskeleton. They bury a lot easier, and not to mention, just like insects today, there's just a lot more of them. I mean, it's one of those things where you're saying there's so many of them in some places, but it's perfectly explained by the fact that they simply fossilize easier. And shale is seafloor mud. I mean, it's perfect place to preserve something. And I don't want to speculate because I'm not into microbial ecology, but we're talking trilobites range from 530 roughly to 290 million years ago. So right around the Permian, the last of them were going out. I mean, we're talking the microbes at the time that would have digested those might have been different. So decay would have been different back then too. But ultimately, they have an exoskeleton. They fossilize easier. They lived at the bottom of the ocean. Not to mention being of their arthropoid nature, there's just going to be a lot of them, and they're going to fossilize easier.
Yeah, but see, that's not happening today. If those things died today, the other trilobites crawling around the bottom of the ocean would disturb them. They'd be turning them dirt in no time. I was on the beach in Sunset Beach in California about 15 years ago. Just walk around the beach out there, and here's a modern clamshell with its integument still intact. The muscle still held two halves together, but one half was starting to break up. Okay, so that's today. That's a hard shell of a clam. A trilobite is like he's like paper compared to a shell. To get millions of those things buried on the bottom of the ocean that currents didn't disturb, other things didn't disturb, it just isn't happening. You can't say there's an explanation for that except a worldwide burial or a decompression of the atmosphere, which killed everything and caused the sediments to start dropping out on that. That would explain it.
The only thing with that is when we look at trilobites, like I said, you could compare them to a clam, and you're right, clams are completely in a different category, mollusca, and they have the hard calcified shell. They're probably going to fossilize easier. In the case of arthropods, we see plenty of them today that die in the ocean. Most of them get eaten up, but at the same time, yeah, they are going to preserve easier. And that is not an accurate claim that they're not going to be found in the bottom of the ocean like they are today.
They're into fossils on the bottom of the ocean today. There's nothing turned to fossils. There's nothing on the bottom of the ocean turning to fossils.
Well, right now it's still very wet.
Oceanic sediments are not an explanation of the vast numbers of
the oceanic sediment is still there today. It isn't dried up. We haven't had the ocean receding. And, because it's our lifetime, it's such a short occurrence. But I mean, what you're seeing here, even in these pictures, for the most part, was the seashore, or even in the creation model, it was still underwater at one point. Rock, in this case, and sediments formed because it has to dry out first. So, I mean, that argument, no pun, it doesn't hold water.
I don't think that's a valid explanation. I know that's a standard explanation, but it doesn't hold water. I've been all over that place. It does not hold water.
So what about, so then I suppose, we could go to the next one that people would talk about, which is the Grand Canyon. One common explanation people say with the Grand Canyon is they talk about how slow and how small the Colorado River is, and they talk about the different mountain peaks and they talk about the different heights while ignoring all the plate tectonics and the age of the Rocky Mountains itself. One thing people ignore, and I even saw this when I was at the Ark Encounter and when I was at the Creation Museum, is they show the Colorado River, and its meandering nature. It's winding like this. When you do an experiment to test out what carves something out, and you take a bucket of water, you go out in your backyard and you dump it, you will always see straight lines. The faster the water, the straighter the lines that are carved away from something. In fact, if you got a flood in your property, you would, in initial washaways, you would have straight carved lines, and they would rapidly erode the side of something. But when we look at the Colorado River of the Grand Canyon, we see lines that are curving. We call them meandering rivers. And physicists can actually use this to calculate the speed at which it is. Because the truth is, the slower the river, the more the carving that takes place. So with the meandering rivers being present on the Colorado, why do flood geologists, I should say, because not all creationists go for this, why do they still say the flood carved the Grand Canyon if there's a meandering river present?
There are two schools, those that say it's carved with the flood, others say it was carved by the lake.
The dams that broke away, but they would say it was still a rapid event.
Either way, you have to have a vast body of water start eroding that thing down and cutting it away. What you're not looking at there, though, is the strata of the Grand Canyon is all flat, and those vacuum lights over there, they're oriented as though they're in moving mud, going a certain direction. There's no way you can say that just got deposited a little bit here, a little bit there, and then 200 feet or 100 feet got deposited. It was laid down by a vast flood and eroded by either the flood and or the Bonneville Lake.
So you're talking again back on stratigraphy, and if actually it's remarkable the technology we have here today that we can look down and we can actually see the layers carved out like you're talking.
Look at the flat layers. Look at them. They're all laid down flat, and a flood does not. Are you
referring to these layers right here?
Yeah, they've all been washed away, so we can see the various layers in there. But that did not happen a little bit at a time. That all happened at one time in liquid water.
Well, if you zoom out further, you also see that this is a much wider place because at the same time, this is something that happened a while ago too, but the general pattern is it's a gradual, slow erosion of meandering rivers, not a rapid pour out of something that's going to lead ultimately to the ocean. It's a gradual erosion.
Well, I'm not talking about the erosion. The erosion is irrelevant. The flat layers is what's relevant. Those flat layers, if you got enough mud on the earth to bury the Grand Canyon, you'd flood the entire earth. Same way in Qumran,
go ahead.
Egypt and Israel at the Qumran caves, same thing. It's all flat layer that's been roached up later on, but it's all laid down flat. The entire world was laid down in flat mud layers, then eroded and convoluted after that.
Okay.
It's the flat layers that are the problem.
Well, I think that goes back to what I was saying before. Why is it a problem with the flat layers? Because it sounds like you keep going back to how could they have been deposited and then they had to sit there for a long time. If I'm not mistaken, I don't want to make an assumption. You keep saying that.
How is that possible? Where can you see that?
You cut out right there. Say that again, please.
I say, where can we see that today in such a vast area?
Well, I was going to zoom out, but I don't think we have to. I think we could just zoom in here and say even on kind of a smaller scale, we can see whenever water recedes, you get some new strata forming, especially if it is a different type of ecosystem. Where do we see it? We see any type of layer form, specifically whenever there is a change in sediment. So whenever the ocean is...
Yeah, well, that's going to be, that sediment there is going to be intersecting the older strata is being intersected by the new deposits. That just proves my point. You don't see that anywhere in the Grand Canyon or Qumran or anywhere else. There's no interruption in those strata. There are no canyons. There's no erosion. That what you're seeing right there should be in every layer on Earth, and it is not there.
If I'm not mistaken, I think there's
all of them.
I think what you're getting at, if and correct me, I think what you're saying is if we look at the stratigraphy of the Grand Canyon, we see, actually, give me just a moment here, my apologies. I think what you're saying is that in the Grand Canyon, we see all the layers in one place, if that's what I'm understanding. And yet when you go to a place like Hell Creek, you see nonconformities where there is disruptions in layers.
Well, no. Wait a minute. What are you talking? What were you talking about? A disruption?
Nonconformity meaning it'll go from like you'll have a layer. Here, let me pull up an image because I'm a very.
You talking about a lens, one layer to another? They're all still relatively flat.
One layer to another. Sorry, my apologies. Let me pull this up here. There we go. So, for example, this is just a picture I'll pull up here. For example, if you go to the Grand Canyon, and I'm just seeing if this is what you're asking, but if we go to the Grand Canyon, you know, we go up at the top here, you'll see a layer roughly like this, and then obviously we go to the bottom, the oldest layers. Grand Canyon being classic example of this geologic period where you have conformity all throughout. But if you go to a place, say in Northeast Montana or the Hell Creek in South Dakota and whatnot, you'll get, for example, we'll have the Cretaceous and you'll have just the last layer right there. And then all of a sudden you'll have several million years missing right there. And that is what we call a nonconformity, because when we go from one layer of the Hell Creek to the next layer, all of a sudden we're missing millions of years in a picture. It's hard to explain it, but what I'm getting at ultimately is, you know, no geologist would say you would expect to see this in every backyard. In fact, where I'm at right now, my grass is actually dating in the tertiary period. But if I go down the road, there's actually trees that are in the Cretaceous layer rocks. It's right on the surface. There's nothing right above it. And the reason why is where I'm living here, I'm actually not too far from the ocean, but all of that got washed away. If I stand out and look more clearly, I can actually see that farther down the hill, the Cretaceous layers are actually lower, but they're actually right on the grassland because all of that stuff above got washed away earlier. The Grand Canyon, the geologists would say, is an anomaly. I think there's 26 places in the world where you can see all the layers almost in a beautiful continuum, but it is an exception. And what that would require to a geologist is every time you had, for example, a Cambrian period, you had a change in ecosystem where the ocean left, came back, and it just happened to deposit a layer of Ordovician rock. Now, it doesn't have to be the entire Ordovician period, but it laid maybe just a little representing somewhere in that time, and then the ocean retracted, solid rock formed, ocean came back in, and it repeated. And the Grand Canyon was one of those rare events which do happen. Rare events do happen. But when you go to other places in the world, like my yard over here, all you'll find is actually not even late Cretaceous. All you'll find is middle Cretaceous layers and very late tertiary, which is where my grass grows. That's what we mean by, I live in Virginia. This is all a nonconformity, meaning all this stuff above it actually was there at one point, maybe, but it got washed away. Oh, another good point to bring up too. I do like going to West Virginia to look up trilobites. West Virginia does not have any dinosaur fossils in it. There has been no dinosaur fossils, at least to my knowledge, discovered in West Virginia. And I remember wondering why that was the case. And then the answer actually was more sad than I realized. And the answer was because when the trilobites, the ones at least I'm finding in West Virginia, they are Devonian trilobites. You can find them fresh on the rock. I usually go to the side of a cutout on the side of a highway where I can find them. And I look in Devonian layers, usually shale type rock. And I don't find them everywhere. I have to keep looking around in shale and roughly I'll find them. But you'll never find dinosaurs. And then you realize it's because it's all the Appalachian Mountains. They are the oldest mountains in the United States. And they have been constantly rising before the Grand Canyon. And all those layers above it never, ever formed because they were always above any ocean that would have washed in. Basically, the top of the mountains of West Virginia are still Devonian. They never did form these top layers because they were always above the ocean. And that is why the Appalachian Mountains are eroded. You'll see trees all the way up to the top because it's eroded into dirt. But when you go to the Rocky Mountains are a much newer mountain. In fact, they're only, I think, less than 100 million years old. And at the very top of the Rockies, you'll see erosion and trees, but at the very top, it's still solid rock. It hasn't fully eroded yet into soil where you'll get all kinds of growth. But that's what I mean by nonconformity. So anyways, Grand Canyon is a perfect example where we got lucky that we have all those layers, but it didn't have to be that way.
I see you're pretty knowledgeable. I've got to go, but interesting talking to you. Uh, as long as you believe those dates, they give all that stuff for uranium dating and all that, you're just going to end up with a false view of things. That uranium dating should all be thrown out as well as carbon-14. That's because we've done the dates ourselves. It's bogus.
Can I ask before, without me even challenging that, just for your respecting you joining me on this discussion, why did it not work out of curiosity? Because uranium 235 decaying that it is a constant. You can heat it up, you can cut it. It's constant.
I've got an email in my files. Can't bring it up right now, but the scientist said there are 30 things we don't know about uranium dating. 15 we can't even test. Well, then let's don't conclude anything by them. It's an assumption. It's based on an assumption that things have always been just like they are right now. We know good well that's not true. Same way with carbon dating. I sent dinosaur bones and mammoth bones and everything else to a chemist who was sending them out to various labs in the country. All the dinosaurs came back within 20 or 30,000 radiocarbon years, which I don't even accept that. Nevertheless, they all had carbon-14 in those bones. So therefore, if we had a rhino from the Gobi Desert, supposed to be 10,000 years old, it carbon dated at 24,000. The Psittacosaurus from the Gobi Desert, supposed to be 80 million, dated at 22,000 carbon years. So did the Stegosaur evolve from the rhino? According to carbon-14, it has to. It's all ridiculous. It bolsters up the atheistic claim of evolution, and people can't challenge it or test it because they don't have the money to do those tests. We did, and we do. And if you look up Guy Berthaud or Hugh Miller, I'm not sure what he's called. What is it called? Anyway, Hugh H-U-G-H Miller. I think you can get him online. Find out his work with the Colby Foundation, whatever. Check out the uranium dates they did and the carbon dates. You'll see what I'm saying. But I've got to go, man. Nice talking to you, and take care of yourself there.
Well, I appreciate you taking me up on the offer and having a discussion. And even though, like I said, I probably am assuming things didn't get swayed, I still feel like it gave me some things to think about, at least from the other perspective. I am skeptical of those last claims made, but I will ask one more thing. What was the museum name?
Mount Blanco
Fossil Museum. Your museum in Texas.
Pardon me? Yeah, that's my museum.
Mount?
Yeah, MT.
Okay.
Blanco, Mont Blanco.
Oh, Blanco. Sorry, the consonant wasn't coming to my name.
Well, I'm anglicizing it.
I understand.
Even they call it Mount Blanco. It's a little white peak in a canyon where all the bones are buried. That's where I've collected for a long, long time. So I named my museum after the local fossil beds where the three-toed horse came from.
All right, Joe. I appreciate it. Thank you very much.
Yes, sir. Have a good night now.
You as well. Thank you.
Bye-bye. Okay.